The focus of this video is to find the horizontal intercepts of the graph of a quadratic function that's given in general form. We normally are looking at all these pieces of the problem. We're going to focus on the fourth one, but let me fill in the answers to the first three pieces so that you can check your answers if you want to do that. When we have general form, then we want to locate our vertex using this formula that we talked about in class. So the first coordinate of the vertex is going to be at minus b over 2a, where the a and b are coming from the equation itself. So the coefficients in the equation of in the definition of the function, the coefficients are the a, b, and c. So the important thing here is these are the numbers in front, and notice that if there's not a number in front, that means that that number is going to be 1 or minus 1. We don't write those in front of the numbers. So a is 1 because that's 1 times t squared. So those are the values of a, b, and c for this particular quadratic. And so the first coordinate of the vertex is given by minus b over 2a. So that means the opposite of b divided by 2a. Since b is negative 3, the opposite of b is positive 3, and we're dividing by 2a, 2 times 1. So that is 3 halves, or 1.5. So we could write 3 halves, or 1.5. To find the other coordinate, I would have to plug in 1.5, or 3 halves, into my definition of my function. So this guy right here. So if I do that, I'll have 1.5 squared minus 3 times 1.5 minus 28. And if you do that, you get negative 30.25. And I'm kind of mixing my fractions and my decimals here, but either one is fine. So minus 30.25. So those are the coordinates of the vertex. The second question asks us which way the graph goes. And that depends entirely on whether this a value is positive or negative. So in this case, because a is positive, since 1 is a positive number, this graph is concave up, meaning it looks like this. The vertical intercept always has equation 0 blank, meaning the input is 0 and we need to find the output. Anytime we're given the input and need to find the output, we're just evaluating. Exactly the same way here, we found the input was 1.5, and so we plugged that into our function to get the output. So f of 0 is easy to calculate in general form. We're putting 0 in place of t, so this is 0 minus 28. So general form is excellent for finding the vertical intercept. And so that's where we have been so far, and now we're going to find the horizontal intercept. And remember, there could be none of these, or there could be one of them, or there could be 2 of them. So we have to go through the process to find out. Actually, if we were to visualize what we have so far, we would already kind of know what's going to happen. Notice the vertex is way, way, way down below the horizontal axis. So this negative y coordinate means the vertex is way below the horizontal axis, but the graph is concave up. So I know that this graph is going to go up towards the horizontal axis in both directions, and so I expect that I'm going to have 2 solutions here. So the idea was find the mystery number for input so that the output is 0. So that's what we're trying to do. We know that the formula given in the function definition is a formula for the outputs. So I need to find inputs so that my outputs, which are given by this formula, is equal to 0. So it becomes a standard algebra solve where the equation equals 0 kind of problem. Now, this is quadratic, and so we've talked about processes for doing this, and the process we were trying first always was factoring, and if you try it, this does indeed factor. But I'm going to go ahead and hit it with the quadratic formula just to make the point that that will work under any situation. So the quadratic formula says that when you have a quadratic of this form, that's equal to 0 when x is minus b plus or minus the square root of b squared minus 4ac divided by 2a. So we have this awesome formula, so we can use it here. Again, the a, b, and c for this particular quadratic are sitting right here. So now I'm just going to use this formula. So x is going to be minus b. Again, when we see minus b, we think opposite of b. So since b is negative 3, opposite of b is positive 3. And plus or minus b squared. B is negative 3, so negative 3 squared is 9. Minus 4 times a is 1, times c is negative 28. So I've just substituted a, b, and c into the top part of this formula, and then the bottom part is just 2 times a. Again, a is 1, so I'll just go ahead and do that. That's 2 in the denominator. So to work with this, we don't want to try to pile all this into our calculator at once. The best way to do it is to first figure out what this number is under the square root sign. If you do that, it'll take a second to do it. And we should have, oops. So we should have x is 3 plus or minus square root. And that stuff under there is 9 minus 112. So 9 plus 112 is 121 under the square root sign. And if you have your calculator handy, you can check and verify that the square root of 121 is 11. So let me just write that a little more clearly. So the square root of 121 is actually a nice number. It's 11. And so my two solutions to this equation are x can be 3 plus 11 over 2, or x could be 3 minus 11 over 2. So that's what we mean by plus or minus. Is that just a compact way of saying it could be either one of these things. So it'd be this expression with either a plus here or with a minus here. And now it just takes a second to do those. 3 plus 11 over 2 is 7. So x could be 7, or x could be negative 4. So these are my zeros. These are the zeros of my function, meaning they're the inputs that give me an output of 0. So if I'm trying to report my answer as horizontal intercept, meaning as a point on the piece of graph paper, then I would write as my horizontal intercept that 7, 0 is a horizontal intercept, and also negative 4, 0 is a horizontal intercept. So this would be my final answer for the question about horizontal intercepts.